Welcome back. Today, got good news and bad news. So we're looking at solving quadratic equations. That's the good news. The bad news is, actually there's more good news, but let me get back to it. So we're solving quadratics. We've looked at that before, so we know how to do it. That part of it is review, but we have word problems. So we have to try to get a quadratic equation out of the word problem before we can solve. So we know how to solve. And then it kind of stinks that we have a word problem. I know this is not everybody's favorite. However, the word problems that we're going to see in this section should be feeling kind of familiar because we actually looked at several examples like these in our rational unit. So hopefully they'll look familiar. And the hard thing with word problems is not one set of steps every single time, but there is a general strategy or approach that we can take. So in general, if I give you a word problem, first thing you want to do is read it. All right, read the problem. If it helps you to mark the text along the way, circle, highlight, draw a picture, whatever is going to help. And then define your variable. Whatever the problem is asking you to find is going to be the variable in your problem. If it helps to organize any further than you did when you marked the text, right, then do that. The hard part is writing a quadratic equation that models your scenario. So you want to write your equation, make sure it models the scenario, and then the solving piece is the piece that's review. You're going to use the appropriate method. Now, we solved problems similar to the ones we're going to see here in our rational unit, but at that point we only knew one method for solving quadratics, and that was by factoring. So we're going to see similar setups in some of the problems today that we've seen before, but we can't necessarily rely on factoring as a method to solve. So it could be the square root method, it could be the quadratic formula, it could be completing the square, whatever is most appropriate or useful for you. And then once we've solved, we want to answer the question appropriately, right? Make sure we have an answer that makes sense for the question. So lots of times we get two answers or both of those answers are going to make sense. We're going to have to make sure, okay? So we're going to start off with one that's relatively easy, in my opinion. It says the width of a rectangle is 4 feet less than its length. Find the dimensions, excuse me, if the area is 96 feet squared. So we've got a rectangle problem here. And not too bad, I should have not lifted the pen, but there's our rectangle. So the width of the rectangle is 4 feet less than the length, and the dimensions of this rectangle are 96 feet squared. So we're trying to find both dimensions, but we don't want two variables in one quadratic equation. So we have to decide, is the length the variable or is the width the variable? And the way we decide is by looking back at what we're given here. It says that the width of a rectangle is 4 feet less than the length. So I know something about the width, which means this is not going to be the variable. So the variable is going to be the length. And I'm going to call it x. Okay, so I'm going to put x here, and it doesn't matter if you had started by putting it here, it's fine, doesn't matter. Okay, so that's my length, and then it says the width is 4 feet less than that. So this side over here is 4 feet less than this one. So 4 feet less than x means I can put an x minus 4 here. So again, this is what I called the length, and this is what oh my gosh, I can't write. This is, where did I erased my box. Guys, I'm falling apart. And it's number 1. Okay, so this is what I called the length, and this is what I called the width. Okay, so there's our length, there's our width. Now we still have to make an equation out of this, and that's where the area of 96 feet squared comes in. Hopefully you remember how to find the area for a rectangle. Area for a rectangle is length times width. So in this case, we know area is 96, and our length and our width are x and x minus 4. So we have 96 equal to x squared minus 4x. And we're going to go ahead and move that 96 over. So x squared minus 4x and then minus 96, and see what's going to be appropriate for solving here. I think this one actually factors, which would be good news, right? Are there factors of negative 96 that make negative 4? Let's see, 8 times 12 is 96. Yeah, if we make the 12 negative, this will work. So this is going to factor into x minus 12 and x plus 8, which means that positive 12 is a solution and that negative 8 is a solution. So two solutions, but remember what x represented was the length of a rectangle. Now, can the length of a rectangle be a negative? Nope. So we're going to eliminate this as a possibility. Length can't be negative. So even though we got two solutions, only one of them is valid for this scenario. So x equals 12 means that the length of our rectangle was 12. 12 units feet. And then the width of that we said was 4 less. X minus 4 would be 12 minus 4, and 12 minus 4 would be 8, so 8 feet. And there it is. All right, and we can definitely verify that that width is 4 less than that length. 8 is definitely 4 less than 12, and if we multiply that length and that width at 8 and 12, we get an area of 96, okay? So I think some of you are probably like, I could have figured that out without the algebra, totally fine. It's just, if it didn't factor, then you'd be looking at decimal amounts and other ways to solve. Okay, so number 2. I like these types. This is a translate problem. So it says 3 times the square of a number is 5 less than 16 times the number, and our job is to figure out what that number is. Let's call it x, okay? So first it says, let me change this color here. Let's define this variable, that number we're looking for. I'm going to call it x. If you want to use n or something else, that's fine. So first it says 3 times. That means 3 is going to be multiplied by something. And what's it going to be multiplied by? It's 3 times the square of the number. So I'm multiplying 3 by the square of the number would be x squared. And then it says is our equal sign. And then we have 5 less than. 5 less than means take 5 away from something. Just gotta figure out what that something is. And that something is, running out of good color options, 16 times the number. So 16 times the number would be 16x. Again, 5 less means take 5 away. So our equation is 3x squared equal to 16x minus 5. So I'm going to subtract the 16x over, add the 5 over to get it in standard form. So 3x squared minus 16x plus 5 equal to 0. And then we'll pray that this factors so that we don't have to solve another way. So let's see. 3 times 5 is 15. And yeah, we can use negative 1 and negative 15 to get a negative 16. We divide 3. And so this is going to factor into 3x minus 1 and x minus 5, which means our solutions are going to be 1/3 and positive 5. Remember, that's the opposites of what we had over here. Now here we're just looking for a number. There's no stipulation on what that number is. It could be a 1/3, it could be a 5, so both answers are going to work here. So we're going to say, let me change colors again. We're going to say the number could be positive 1/3 or positive 5. Either one of those satisfies this criteria. Okay? So I have a translate one here for you to try. Feel free to pause and give it a shot. Otherwise, let's see. 9 more than the square of a number is 58. We're going to find the number. Again, I'm going to call that number x, although if you like another variable, knock yourself out. So 9 more than means 9 plus the square of a number would be x squared, and then is our equal sign, and then 58, nothing to translate there, right? 58 just comes down 58. So our equation is 9 plus x squared equals 58. Now we don't have to worry about factoring on this one because we don't have an x to the first term. So we're just going to subtract this 9 over, and then we have x squared equal to 49. And now we're going to take the square root of both sides, which means x is going to equal, don't forget your plus or minus, 7. And again, we're looking for a number. Positive and 7 both qualify. So we're going to say, we're going to say the number could be, in this case, 7 or negative 7. Okay? All right, so far, hopefully manageable. Let's look at what we got coming up next. So, favorite. My favorite, no, probably not your favorite either. Distance, rate, time problem. So, I think we looked at one in class together with a canoeist, and we laughed a little bit about never writing the word canoe before, or canoeist before, I mean. So here we have Abby. She rode 10 kilometers upstream and 10 kilometers back downstream in a total of 3 hours, and the speed of the current was 5 kilometers per hour. We're trying to find Abby's speed. So Abby's rowing speed, let's call it x. Now this is going to be a distance, rate, time problem. If you remember, we set these up by making a table where we put in distance, rate, and time for, in this case, each trip. One trip upstream and then another trip back downstream. All right, then we're going to fill it in and decide which version of the formula we were going to use, right? It was distance equals rate times time, or time equals distance divided by rate, or rate equals distance divided by time, depending on what we're given, okay? So let's fill in our information. So 10 kilometers upstream, 10 kilometers back down means the distance both times was 10. Now the rate is the speed, so I know there's going to be x in both of these columns. We don't know her speed going up or down, but there's also the speed of the current that we have to factor in here. And remember, what happens is upstream the current is slowing you down because you're working against it. So whatever her speed was, she's 5 miles per hour slower going upstream. And then downstream, you're going with the current, it's speeding you up. So whatever her speed was, she's 5 miles per hour faster going downstream. So we add or subtract to the rate, and we add or subtract the current with that rate. And then time was a total of 3 hours. Now, I don't know how much of the 3 hours goes in either one of these spots, and so this is what's going to tell me which formula I'm using. Since the time spot is empty, that tells me to use the time equals version of the formula. So time is equal to distance divided by rate. So I'm going to take my distance of 10 and divide it by my rate of x minus 5, and the same thing here. Distance divided by rate has to equal time, and the total time for these two trips together has to be 3 hours. So our equation is going to be 10 over x minus 5 plus 10 over x plus 5 equals 3. Now that's not a quadratic equation yet. Right now it's a rational equation. But if you remember, in our rational equation, we want to get rid of the fractions, and we do that by getting a common denominator. Once the denominators are the same, we can ignore them and focus on our numerators. So our common denominator here, least common denominator, is going to have an x plus 5 and an x minus 5. So just so we're clear, this is over 1. This fraction would have to be multiplied by an x plus 5 on the top and the bottom. Here we'd have to multiply by an x minus 5 on the top and the bottom. And then here, we'd have to multiply by the whole thing, because this denominator only has a 1. Not really helpful. Okay, so now that all of our denominators match, x plus 5, x minus 5, x plus 5, x minus 5, x plus 5, x minus 5. Now we can focus on our numerators. So from this numerator, 10x plus 50, plus here 10x minus 50, 50 equals x plus 5, x minus 5 is x squared minus 25, multiplied by 3 is going to be 3x squared minus 75. And so if we clean this up, this is 20x on this side, and then these cancel, and we still have 3x squared minus 75 here. So I'm going to get it in standard form. I'm going to subtract the 20x over. And then let's see, is this bad boy going to factor? So 3 times negative 75. 3 times 75. Oh, I feel like I should know that. It's negative 225. Are there going to be factors that make 20? So we used 3 and 75 to get it. Let's see. 25 goes in how many times? 6? No, I can't divide, guys. My brain, I'm sorry, long pause while my brain's trying to divide and it's not happening. 9 times sounds better. In any case, that ain't gonna work. Let's see, 5 is gonna go in 45 times. I do not think we're gonna get to a difference of 20. Now, I could verify with the discriminant, right? B squared. Let me do this in the calculator. If I use the discriminant and I get a perfect square, that means I can factor. So b squared negative 20 squared. Oh my, what am I doing? Squared minus 4 times a is 3 and c was negative 75 is 1300, and that is not a perfect square. Square root of 1300 is a decimal, so this is not factorable. So not factorable, which means we have options. I think complete the square would not be a good option here because I'd have to divide everything by 3, and that would put a fraction in the middle. Can't use a square root method because 20x is in there, which means this has to be solved using the quadratic formula. Woohoo! I know you're thinking that right now. So we're going to plug in 3 for A, negative 20 for B, and negative 75 for C. So x is going to equal a negative b plus or minus the square root of b squared. Oh man, on fire here. B squared minus 4 times a times c, all divided by 2 times a. So this is a mess. X is going to equal negative negative becomes a positive 20, plus or minus. In the calculator, we already got 1300 for that radicand, and then 6 on the bottom. Now, let's go to the calculator. Now, normally I would say if this problem had no context that we would want to simplify that radical and get an answer in simplified form, but we're really looking for, remember, a time or a speed, I mean, for Abby, and we're not going to give a speed in terms of a radical. So I'm going to go straight to the calculator here and say that this is going to be approximately, calculator, we've got 20 plus radical 1300, and that is all going to be divided by 6, and that's going to be 9.3-ish. So 9.3 was a possibility. And then if I change that plus in between there to a minus, wow, I'm falling apart. Really? Was my 0 there? Jeez. Okay, so change the, apparently easier said than done. Change the plus to a minus, and then we're looking at a negative 2.7-ish. Negative 2.7. So those are the two answers. Obviously, can't have 2 speeds for one Abby, and her speed can't be negative. She can be slow, but not negative. So we're going to eliminate the negative 2.7, which means her speed is about 9.3, what are our units here? Kilometers per hour. So Abby's speed is about 9.3 kilometers per hour. Okay, so we set up problems like these before, even cleared out the fractions. All this is the same. Just last time we saw it, we were able to factor, and that just didn't happen here, but that's okay. We've got the quadratic formula that can solve for us too. Okay, now number 4 is also a type that we've seen before. This is a work rate problem. So we have Tanner and Joel can grade their students' projects in 2 hours. Working alone, it would take Tanner 2 hours longer to grade the projects than it would take Joel. How long would it take Joel to grade the projects if he was working alone? So Joel, working alone, don't know. I'm going to call that X. Now, if you remember how we set this up, we've got Tanner plus we have Joel, and that would put them working together. Hopefully this is looking familiar. If you want more details on some of this, go back to your rational applications of rational equations notes, and you'll be able to see some more detail on how we set this up. But for now, Tanner says he takes 2 hours longer than Joel. Now Joel we didn't know, so we're going to put X there. If Tanner takes 2 hours longer, X plus 2 there for Tanner, and then together takes them 2 hours, so 2 over here. Now if we just made the equation like this, we'd have 2x's, oops, this is an equal sign. We'd have 2x plus 2 equal to 2. We'd subtract the 2 over, which would mean 2x would equal 0, and then we'd get an answer of 0, which wouldn't make any sense, okay? Joel's not going to grade projects in 0 hours. Remember, there was one more thing we had to do with this. We had to convert each of these amounts to rates. And so remember, if they took 2 hours to do these projects total, how much of the job was done in 1 hour was 1/2 of the job. So to convert the amount to a rate, we were just putting a 1 over it, right? It was technically the reciprocal. We reciprocate the number, but since it's 2 over 1, it becomes 1 over 2. This needs to be 1/x of the job per hour here, and then 1 over x plus 2 of the job per hour here. So to convert the amounts to rates, you put a 1 over it, or it's the reciprocal of that amount. All right, so now it's like the last. We got to get rid of these fractions. So we're going to get a common denominator. In this case, our common denominator is going to have a 2 and an x plus 2, each of those pieces. So here we're going to have to multiply by a 2 and an x. Here we're going to have to multiply by a 2 and an x plus 2. Let me move my equal sign. 2 and x plus, son of a green, 2x plus 2, and this last one we're going to have to multiply by x and x plus 2. So now let's just check these denominators. 2x, x plus 2, 2x, x plus 2, 2x, x plus 2. Good. So now that all of those denominators match, don't need them anymore. Now we can solve using just our numerators. So in this numerator, 2x times 1 is 2x. Plus in this numerator, 1 times 2 is 2. 2 times 2 is 2x, and then 2 times x is 2x, and 2 times 2 makes 4. And then here, 1 times x is still going to be x, times an x makes an x squared, x times 2 makes a 2x. So this is 4x plus 4, and then x squared plus 2x. And then I'm going to subtract these guys over. Subtract over 4x and 4. So I get my 0 on one side. So 0 is going to equal x squared minus 2x minus 4. Now I can see that's not going to be factorable. Again, that's the only difference between us doing this problem now and when we do it in our rational unit. So not factorable. Can't use the square root method because that 2x is in the middle there. Now, if I was solving this problem, I think this is a good candidate for complete the square. If you don't like completing the square, then use the quadratic formula. But I'm going to complete the square, and I want you to have some variety in your notes. So completing the square, we move the constant over. We're looking at x squared minus 2x plus something here, and then we're going to move the 4 to the other side. Again, negative 4 here becomes a positive 4 on the other side, and I need more space. Give me a second. I'm going to move all of this over. And not make too big of a mess here. Okay, so I'm just moving the 4 over. And then remember, I'm trying to add something to both sides to complete the square. So in this case, let's see, I'm adding half of b is half of negative 2, half of negative 2 is negative 1, and then I square that to get a positive 1. So adding positive 1 to both sides. So this gives me factors of 1 that make negative 2 are negative 1, negative 1. So this is going to factor into, why did I go to blue? I'm not sure. This is going to factor into x minus 1, or x minus 1 squared. On the other side I have a 5. Now I can square root both sides. So I have x minus 1 equal to a plus or minus radical 5. And then I'm going to add that 1 over. Not like terms there, so we're going to have a 1 and a plus or minus a radical 5. Now, without context, I'd say let's leave it there, but since we're looking for a time for Joel and Tanner working on projects here, let's put this into the calculator. If we have, what was it, 1 plus a radical 5, that is about 3.2. So 3.2, and then if I change that to a minus, negative 1.23. And again, this we're going to eliminate as a possible solution. They're not working in negative time. It doesn't exist. So 3.2 was, remember, joule. That means joule takes about 3.2 hours. And that's all it asks, right? If it asked for how long it took Tanner, he takes 2 hours longer. So if it asked, we would say Tanner takes about 5.2 hours. If it asked. But it didn't, so if you didn't put that part on there, that's totally fine. All right, so I have one last one here. If you want to try it out, feel free to pause the video. If not, let's knock this thing out. So the distance d of a falling object after t seconds is given by d equals 4.9 t squared plus 30t. If a coin is tossed from an altitude of 75 meters, how long will it take to hit the ground? So this one is kind of nice because we already have an equation. Well, actually we have a function, but the function is still an equation. It's got two variables in it, and what's happening when you're already given an equation like this or a function like this is you know the value of one of the variables and you have to find the value of the other. So a coin is tossed from an altitude of 75 meters. That means we have a distance of 75 here. And then it's saying how long is it going to take to hit the ground. So why am I, sorry, my brain just went. Oh yeah, geez, guys. Okay, so how long means we're looking for a time. How long is it going to take for it to hit the ground means how long is it going to take to go all 75 of the meters down, right? Start 75 meters up, we're looking for how long does it take to travel all 75 of those meters. I don't know why I got hung up on that for a second. Okay, so we're given the value for one of the variables. We want to plug it in and figure out the one that we're missing. So we have 75 equal to 4.9 t squared plus 30t. And let's subtract that 75 over. I don't know about you, but I do not think this is going to factor, and I definitely don't want to try to complete the square, and I can't square root, which means we have another quadratic formula candidate here. So we're going to put in 4.9 for A, 30 for B, and then negative 75 for C. So if you weren't trying at this point, I would say pause and see how you do on the quadratic formula here. So we have x equal to negative 30 plus or minus square root 30 squared minus 4 times 4.9 times negative 75, all divided by 2 times 4.9. So we have negative 30 plus or minus, under the square root, we have 30 squared minus 4 minus 4 times 30, no, 4 times 4.9 times negative 75. Okay, so 2,370. Yep, 2,370. And on the bottom, 2 times 4.9 is 9.8. Now, without context, again, we would probably simplify that radical. Thankfully, there is context and we can just approximate it. So let's go to the calculator. We have a negative 30, and we're going to add a square root of 2,370. And then all of that is going to be divided by 9.8. So about 1.9 was one of the answers. And then if we change the plus to a minus, we get a negative 8.0, which, again, can't apply for this situation. So we're going to eliminate the negative option. which means our answer here is 1.9. It's going to take about 1.9 seconds for this object to travel all 75 meters from where it was to the ground. So about 1.9 seconds. All right, there it is. Sorry for my weird pauses, moments of thought. I don't know if you're looking at the timestamp here, but this is really late at night. I meant to do this earlier, but you know, kids, Easter, things happen, so bear with me. Anyway, I appreciate you guys. If you have any questions, as always, email me. By the way, we only have one more set of notes for this unit, so our quadratic functions coming tomorrow will cap it off, which means you got a quiz coming up. I'll put more details in the announcement.